So this lesson is about percent yields. When you go into a laboratory and you do an experiment, you don't always get as much product as you would expect to get. What you expect to get is your theoretical yield. What you actually get is, something less than that. And a percent is a measure of how close to that theoretical yield you obtained. What you obtained, how close was it? Okay? So let's get some definitions. Theoretical yield. Theoretical yield is what we've been calculating. When you calculate with pencil and paper and a calculator, and you're doing dimensional analysis, you are doing a theoretical yield. How much should form if it all had a chance to react? If you go into the laboratory and you do the experiment and you collect the product formed, that's called the actual yield, because you actually went into the laboratory. You actually collected it. You actually weighed it out and you saw how much was actually there. That's an actual yield. Okay? It is almost always less than what you calculated it should be for lots of different reasons, and we won't go into them right now, but we can consider one. It was just maybe difficult to collect all the product, and you weren't able to obtain it all to weigh it all out. So that is almost always smaller than your theoretical. So percent yield is same as any percent. A percent is the part. Now of those two things, what's the part? The actual yield over the whole. The whole amount you should be able to get is the theoretical yield times 100. That's what percent always is. Actual over, the part over the whole times 100. You just got to figure out what the parts and the wholes are. In this case, the actual is the part, the theoretical is the whole, times 100%. So those are the definitions. With those definitions, we can work a problem. In this problem, we're talking about this reaction you see here. You take carbon monoxide, you react it with hydrogen, and you can produce methanol. Okay, that's not a hard reaction. Now, carbon monoxide is a very poisonous gas, so you wouldn't want to do this out in the open in the air, but that will make our methanol. Now here's the problem, and the reaction I've rewritten down there at the bottom of the screen. In this problem, I'm going to start by saying how many grams of methanol can be made from 10 grams of carbon monoxide if it all reacts. Having that if it all reacts means if we could get everything out, in other words, what is its theoretical yield? So we're going to start with 10.0 grams of the carbon monoxide. Before I keep going, sometimes they'll say is made from 10 grams of carbon monoxide reacting with an excess of hydrogen. That doesn't make it a limiting reactant problem. I already told you what's in excess, the H2, okay? So sometimes it's written that way, and you might want to put that in parentheses on the side. I'll say it again. When 10 grams of carbon monoxide reacts with an excess of hydrogen, they're telling you you can base the whole problem on this. So we're going to get how many grams of methanol? What do we do first? Well, all roads lead into the moles. So we go to moles of carbon monoxide. We go to the periodic table. We take one carbon, one oxygen. That gives me 28.01 grams. That always goes with the grams. And that goes with the moles. Now that got me into moles. Now I'm ready to go over the bridge to my unknown, what I'm asking about. I'm asking about the CH3OH. So I go from moles of carbon monoxide, so it'll cancel, to moles of CH3OH. Where do I get those numbers? Well, they come from the balanced equation. There's a 1 in front of both of those in the balanced equation. Now I'm ready to go on out to finish the problem. It asks me how many grams of CH3OH would be obtained. So I'm going to go to grams of CH3, oops, that's not a C, H3OH. So again, I go to my periodic table. I add those values up and I have 32.042 grams in a mole. And when I multiply all that together, I will get 11.4 grams of CH3OH. Now, how could this question have been worded differently? It could have said, calculate the theoretical yield of CH3OH. Calculating the theoretical yield means how much formed. calculating wise. Okay, so I have calculated the theoretical yield. It meets the definition of theoretical yield. All right, let's move on to the next part of this question. It says A, so there must be a B. I did that part. B, if 9.55 grams of methanol was recovered when the amounts in part A were used, what's the percent yield? So the question I have for you is, they gave me 9.55 grams of CH3OH. What is that they've given to me? Well, that's the actual yield. And they won't always say, hey, the actual yield is, and give you a value, but they'll give you words that tell you you collected it. You went into the laboratory and obtained it. So words like collected, obtained, was produced. It'll tell you how much, okay? We're not going to send you in the lab to figure out what the actual lab yield is. We would have to give that to you. So if we're asking for the percent yield, then we just have to pull out the part, that's the 9.55, over the whole, which was 11.4, and it's in a percent, so we multiply by 100, and that's going to give me 83.5%. So when the reaction took place, you got 83.5% of what you calculated you should have obtained. That's the percent yield. Variations on this theme, they might say, well, when you do the experiment, they give you this and say, well, then what's the actual yield? Okay, how much would you actually obtain if you knew the theoretical? So we rarely give you the theoretical unless we're just trying to speed things up, because you can calculate the theoretical. But we might give you the actual and ask you to get the percent. We might give you the percent and ask you to figure out what the actual value is.